Today's topic is section 9.5, composition of transformations. Our goal is to perform combinations of two or more transformations. Our first definition of today is composition of transformations, which simply means two or more transformations. A special type of composition of transformations is called the glide reflection. The glide reflection is a translation followed by a reflection across a line parallel to the translation. Our first example. The vertices of triangle PQR are given as such. We have point P, Q, and R. So we have PQR. It says find the image of PQR after the glide reflection. So you have PQR. The first thing you're going to do is translate PQR using the mapping rule here. Again, this will be 4 right. Since it's Y, we're adding 0, so there's no up or down movements. We're just going to count over each point and label them as the prime version. We now have P prime, Q prime, R prime after the first transformation, the translation. We are now going to reflect over the x-axis. Since we went straight sideways with our translation or our glide, you did a horizontal line. So any horizontal line, like the x-axis, reflecting over that makes this a glide reflection. And now since we've transformed Q twice, it'll be Q double prime. P double prime. And R double prime. And we now have Q prime, P prime, or I'm sorry, Q double prime, P double prime, R double prime as a triangle. That is your resulting image. For your homework and on your quiz, you will need to show all 3 triangles. Here's another example. The endpoints of MN are -2, 1, and 3, 4. Graph the image of MN after the composition. We're basically doing things we've done in the previous couple sections. Number 1, reflection over line y equals x. So if we remember y equals x, AB becomes BA. So M prime will be the point 1, -2, and N prime will be the point 4, 3. And if we think about it, our line of reflection was there for y equals x. All right, and then we will draw our segment M prime, N prime. Now we need to rotate each of these points 180 degrees about the origin. To do this, AB becomes negative A, negative B. So we're going to take our M prime of 1, negative 2, and that becomes M double prime, which is negative A, negative B, so the negative of 1 and the negative of negative 2. And we will do the same thing with N prime. And we get negative 4, negative 3. And we draw that segment. This olive colored segment is our final segment. The M double prime, N double prime. One of the theorems that comes about in this section is the double reflection, or the parallel reflection theorem. When a point P, or Q, doesn't matter which one, is reflected across parallel lines, the distance from the original image, or the original pre-image P, to the resulting image P double prime is twice that of the distance between the parallel lines. So whatever the distance between K and M is called D. This segment here is D. P to P double prime, or Q to Q double prime, also 2D. So it says here the distance of P to P double prime is 3.2 meters. What is the distance between the K and M? All of these problems are going to be a matter of, am I doubling the distance between the parallels to find the overall, or do I have the overall and I'm dividing by 2? So what we'll do is say 3.2 equals 2D, divide both sides by 2, and get that D equals 1.6. And in this case, we have a unit of meters. This also works with intersecting lines. So the intersecting lines reflection theorem. So when you have intersecting lines, they are going to meet here at an angle we call X. The distance between the original segment or original triangle or whatever you have to the end, that angle will be twice X. So same type of problem as with the double reflection or reflecting across parallel lines. When you have reflecting against rotated or intersecting lines, we end up having a rotation. So it says, describe the single transformation from the blue image to the green, meaning there's point A, there's A prime, there's A double prime. So it's asking for what is this angle. Again, this is either dividing by 2 or multiplying by 2. In this case, we are going to multiply by 2. And this can be classified as a rotation. So keynote here, a reflection across parallel lines would be a translation. The reflection across intersecting lines is a rotation.